General, termites are the most destructive of all wood-destroying insects. Termites use wood for food and shelter. They feed on alive/dead wood, cardboard, paper and other products that contain cellulose. Termites are social insects. There are 3 types of termites in the US: dry wood, damp wood, and subterranean. Only eastern subterranean termites are commonly a pest in our damp wood termites are found in Florida and the Pacific coast. Subterranean termites live underground, distributed broadly within connected chambers and tunnels versus a single nest, are found in 95 over 99 counties in Iowa. Some areas can be heavily infested, while adjacent areas have no activity. Most commonly found in southern Iowa, but are found spottily in northern Iowa. Drywood termites, not native to the Midwest, but sometimes are found in Iowa. Furniture transported from the southwest and southeastern US attack structures where infested furniture is kept. Attack drywood and are not dependent on a constant, abundant moisture supply. Are larger and subterranean termites. Termite life cycle: simple life cycle similar to cockroaches. Egg, nymphal, adult. Have adult polymorphism for different adult labor within colony. There are 3 castes: reproductive, kings and queens, also called alates, worker, and soldier. Workers and soldiers are non-reproductive/sterile. Primary reproductive swarm, called swammers, during swarming flights to attempt to establish new colonies, have compound eyes, and are dark brown to black in color. Reproductives are the only termites to have wings. Swarmer reproductives are often confused with winged ants. Termites have uniform sets of wings and vertical antennae as well as a thick waist. Ants have different sized signs and bent antennae as well as a pinched waist. Secondary reproductives in the colony stay at the nest to breed and replace the queen quickly if needed, and have poorly developed wings and never swarm. Are less pigmented, do not have compound eyes. Workers are the most common and are inch in size and nearly or totally blind. They lack compound eyes. They are soft-bodied and a creamy white color. Soldiers have greatly enlarged heads and mandibles. They are also considered sightless and are soft-bodied and a creamy white color. Swarming: swarmers generally emerge on warm sunny days when the humidity is high. Swarming can occur any time that proper conditions are met, but is most common in spring after a brief week flight. The wings of swarmers break off, and the males and females mate to attempt to establish a new colony. Nearly all are unsuccessful, and they perish or are eaten by predators. Successful mating leads to female laying eggs in moist wood or soil. It takes several years for the colony to reach its maximum size. 0.5 to 5 million termites. Workers foraging for food in good locations may establish a subcolony with several workers, soldiers and perhaps secondary reproductives. The subcolony will work with the home colony until they are, for numerous reasons, cut off and are with the principal mode. If dispersal and colony initiation is by division. Termite physiology: termites digest cellulose. Few other animals have this ability. Termites prefer to feed on wood that has been attacked by fungi. Termites can digest sound and undecayed wood, but decayed wood is preferred and eaten faster. Termite activity in wood increases as the moisture content improves conditions for decay. Fungi: termites help to disseminate fungi by carrying fungal spores on their bodies and dropping it in feces. They farm fungus. The fungus is eaten by the termites for protein and vitamins that would not be met by eating wood alone. Termites have in their gut a mass of one-celled organisms that give them the ability to digest cellulose, consisting of protozoa, Actria, amoebae, and fungi furnish the enzymes that actually digest the wood fragments. If removed, the termite will starve to death. Termites acquire the organisms through trophallaxis, when termites molt or lose all their hind gut contents, and must reacquire through trophallaxis. Subterranean termites require a plentiful constant source of moisture. Secondary reproductives: workers and soldiers are soft-bodied and lose water upon exposure to dry air. Mud tubes are constructed to keep termites in a moist environment, also providing an ideal environment for the fungi. Termites obtain moisture from 4 different sources. 1. Digestion of wood, metabolic water. 2. Residual water present even in seasoned wood, 20%. 3. Water picked up by wood in contact with soil, damp masonry or concrete, or leaking plumbing. 4. Soil termite colonies in exposed areas sense the change in temperature by fall and move downward at least 3 feet, where the necessary stable conditions of temperature and humidity can be maintained. They move upwards again in the spring. Termite signs and symptoms. There are typically 3 signs of termite infestation. 1. Swarmers or their shed wings. 2. Mud tubes on the foundation or structural members. 3. Damage to the wood. The presence of swarmers in a house or building does not prove the building is infested, but it is good circumstantial evidence. The discarded wings of termite swarmers are frequently found on windowsills and in light covers. Termite shelter tubes, mud tubes, are hollow passageways that conceal termites as they move over things they cannot eat. Preservative treated wood, concrete, nettle, and hard lumber single tubes when built in the open are about the diameter of a lead pencil. Tubes may be larger to accommodate more activity. Tubes in active use generally appear moist and strong. Old tubes appear dry and brittle. The damage from subterranean termites differs from all other wood-destroying insects. The wood is excavated and consumed by the workers, leaving cavities and tunnels in the wood. The galleries run with the grain, because termites primarily attack the soft lighter-colored springwood of the annual rings, leaving the hardwood looking like pages of a book. The most distinctive of subterranean termite damage is the light brown dirty material that lines the galleries. This pasty coating contains soil particles removed during excavation of underground colony chambers, moist fecal material, and glue-like substance secreted by the termites. As a general rule, termites are found near or below ground level. Occasionally they may attack higher areas within the structure. Subterranean termites leave pelleted or powdery frass within the damaged wood, as do dampwood termites and post beetles, nor do they leave behind piles or packed tunnels of coarse sawdust typical of carpenter ants and some wood-boring beetles, respectively. Conditions that favor termite attack. Any house, regardless of construction methods or materials, may be attacked by termites. Certain conditions favor termite establishment and make a wooden structure more vulnerable. Wood to ground contact. Decks, steps and wooden flower boxes should not rest directly on the ground, but should be separated from the ground by cement or metal. Wood siding, piers and wooden steps should not be closer than 6 inches to the ground. Abundant food within the soil. No wood or wood products should be buried in backfills against the house. Cracks or voids within the soil. Termites can easily crawl through tiny cracks in foundations and concrete floors to reach wood that does not actually touch the soil. Cracks as small as 1/32 of an inch permit entry of termites. Crawl spaces. Soil within crawl spaces that is warm and moist close to wooden joists improves termites' chances of infesting. There should be at least 18 inches, 30 is preferred, of clearance between floor joists and the ground. Crawl spaces should be ventilated to prevent excess moisture. Vents should furnish 1 to 2 square feet of vent area for each 25 linear feet of foundation wall. Poor drainage. Soil surface should slope away from the building and eaves and downspouts should carry water away from the foundation. Water leaks, slow leaks in plumbing, or condensation from cold water pipes may provide the moisture needed for termite survival. Leaked roofs, rain gutters, flashing, siding and constructions joints also may be a source of moisture. Termite inspections and reports. Termite damage is seldom noticeable on the surface of wood. Inspection does not involve the removal of plasterboard, paneling and other wall and ceiling treatments, or of molding. Inaccessible areas should be indicated in your inspection notes and on the inspection reporting form. Non-visual inspection methods exist, but are not widely used or accepted as viable. Dogs, methane flooding. Hearing devices. New termite inspection regulation. As of November 1, 1995, anyone performing termite inspections must be certified. They must hold the Iowa Commercial Applicator License and certifications for 7B. For the purposes of this rule, wood destroying insect means subterranean termites, carpenter ants, and powder post beetles. Reasons for termite inspections. Inspections may be done after treatment to determine if there is an infestation. Usually annually. WDI for homes properties being sold may be referred as VA or FHA inspections. Equipment, good lights or still for probing. Awl, ice pick, slender screwdriver or other pointed object for probing. Care must be taken To not mar or damage the property, object for sounding a light hammer or handle of a screwdriver for tapping wood. To listen for hollow sounds that may be evidence of termite damage. Graph paper and a pencil. Drawing a diagram to scale and taking notes are necessary for a thorough and complete inspection. Measuring equipment. A carpenter's tape measure to measure the inside and outside of the structure. Additional items. Overalls. Small mirror on the end of a handle. Magnifying glass. Bump helmet / hard hat. Knee pads. Respirator. Moisture meter. Ladder. Camera. Computer software. Inspection procedures. The clearest sign of an infestation is active workers within a house or building. The presence of swarmers does not prove that the building is infested. Mud tubes are a sign of past activity and are difficult to evaluate. Tapping and probing with a sharp tool is a method for detection. If termites are active while probing, you will notice workers. Carpenter ants also make galleries in wood, but they are smooth, clean and do not contain powdery debris. Powder post beetles damage is evidenced from random, small exit holes with a flour-like powder often seen trailing down from the holes. Exterior inspection. Walk around inspecting and draw a diagram that will serve as a visual record. Items to be noted: improper grade, faulty drainage, firewood or wood debris next to the foundation, untreated wooden structural members in contact with the soil, siding less than 6 inches above the outside grade, faulty eaves and downspouts, poor condition of roof, damage or infested wood, termite shelter tubes on the outside of the foundation. Living insects found inside damaged wood or in termite tubes. Inaccessible areas, dirt-filled porches. Attached exterior planters, patio slabs, attached and unattached garages, and other outbuildings or fence posts next to the foundation. Interior inspection. Difficult due to furnishings. Probing can be done inside cabinets, beneath sinks, in utility rooms, and in garages. Crawl spaces. Standard clearance between the soil and lower edge of joists is 18 inches. Need to be inspected thoroughly as it is often the area with the most favorable conditions. Probing should be done in box sills, sill plates, and floor joists as well as around all support piers. Notate conditions conducive to wood destroying insects. Inadequate ventilation in the crawl space. Presence of wood debris, wood to ground contact, standing pools of water, moisture on foundation walls or wooden structural members, water leaks under bathrooms, kitchen, and utility room support posts or piers. Indirect contact with the soil. Termite inspection reporting requirements. As of October 1995, the new form is the NPCA-1 and is valid for 90 days. Required by all FHA and VA insured mortgage loans. Prevention and control of termites. Generally, buildings become infested when little or no attention is paid to the preventative maintenance construction practices for termite prevention. The objective of preventative procedures is to block termite access to wood and moisture building site. Roots, stumps, and other wood debris should be removed. Wood and lumber should not be left where not required. Removing these items can reduce the likelihood of infestation. To prevent moisture, soil should be graded so surface water drains away from the building foundation. Penetrability. Cracks as small as 1/32 of an inch can allow termite access. Decreasing order of foundations resistant to termite penetration. Poured concrete foundations, hollow brick or brick foundations, and piers, wooden piers, or posts used for foundation/piers to further reduce termite access include capping block with 4 inches minimum of reinforced poured concrete or precast concrete blocks with all joists filled completely. Wooden piers and posts should be made of pressure treated wood and set on concrete bases. Metal termite shields, sometimes used in place of a concrete cap, to seal masonry foundations. Properly designed and installed metal shields will force termites into the open where they are vulnerable. Frequent inspection for mud tubes on shields is important, only recommended, and no shield has been developed yet that is absolute in preventing the passage of termites. Wood to ground clearance. The outside finished grade should always be at or below the level of soil in a crawl space. Exterior siding should not extend down more than 2 inches below the top of the foundation walls, piers, and concrete taps. Exterior siding should be at least 6 inches above the outside grade crawl space. Minimum clearance between the ground and the bottoms of floor joists 18 inches clearances for girders should be at least 12 inches. Ventilation beneath buildings should be large enough and placed properly to prevent humid conditions that favor termite activity and wood decay. Openings placed within 3 feet of the corners of buildings usually give the best cross ventilation in general. The total area of ventilation opening should be equivalent to 1/150 of the ground beneath dwellings, where there is a tendency for moisture to accumulate in crawl spaces, or where adequate ventilation is difficult. A vapor barrier over the soil surface is advisable. Polyethylene sheeting, 4-6 milliliters in thickness, is acceptable. Wood to ground contact, door frames or jambs should not extend into or through. Concrete floors. Porch supports adjacent to a building should be separated by 2 inches. Wooden steps should rest upon a concrete base or apron that extends at least 6 inches above grade. Window frames or other openings near or below grade, made of wood, should be at least 6 inches away from soil. Wooden lattice or skirting should be at least 2 inches away from soil. Wooden basement partitions, posts, and stair carriages should be placed after the concrete floor is poured and never extend into or through the concrete. Use concrete footings that extend about 3 inches above the floor level under wood posts, stair carriages, heating units, and other load-bearing points. Concrete slab on ground construction is one of the most susceptible types of construction for termite infestation, and often give a false sense of security. Termites can gain access to the building over the edge of the slab or through expansion joints, openings around plumbing, and cracks in the slab. Slabs vary in their susceptibility to protection from termites. Monolithic slab, supported slab, floating slab. Floor and footing of monolithic slab is one continuous operation, so that there are no joists or other structural features. Supported slabs in the foundation are constructed as independent units, and the floor extends completely or partly across the top of the foundation. The top of the slab should be at least 8 inches above the grade. Floating slab is independent to the foundation. Because slab on ground construction is so susceptible to termite attack, infestations are difficult to control. Pre-treatment of the soil with termiticides before placement is recommended. Pressure-treated naturally durable wood, where wood must be in direct contact with the soil, placed close to the soil, or in an area where moisture is likely to be a problem. Pressure-treated or naturally durable wood should be used only. The heartwood of naturally durable wood is resistant to termite attack. Available resistant species are eatern, red cedar, and redwood. Chemically treated wood resists attack by both termites and decay. However, termites are able to build shelter tubes over both types of wood to reach susceptible wood. Termite prevention and control with termiticides. The objective of applying a termiticide to seal is provide an unbroken chemical barrier between the wood in the structure and the termite colonies in the soil. Must be applied thoroughly and uniformly. Pre-treatment, often most effective when done before and during construction of the foundation, should be used in conjunction with good construction practices and not used as a replacement for it. Particularly important when using concrete slab on ground foundation. Post-treatment, chemical soil treatments can control termite infestations in existing buildings. Plumbing, ductwork, electrical wiring, and probable occupation by people or their pets means that extreme caution must be exercised when chemical applications are made to existing structures. Application of termiticides. Termiticides are applied with water emulsions and are stable once it dies in the soil. Leaching is often not a problem, as most termiticides used are insoluble in water. There is a slight risk of contamination to a well or other water supply if not applied correctly. May vary with soil type, grading, water table, well location, the design of the structure, and other factors. Guidelines are provided. The 4 most common methods of applying termiticides: broadcast spray, trenching, rodding, treating, backfill method. Broadcast application. A low pressure broadcast spray may be used to apply termiticides as a pre-construction treatment after grading and filling is complete and before the slab support points. To remember about broadcast spraying include: use a low nozzle pressure of 25 C or less. Avoid treating the entire crawl space. Do not treat areas intended for use as plenums. Apply termiticide solution at the rate specified on the label. The treatment of fill under slabs extends probably less than 2 inches in depth, with the majority of the insecticide being in the top inch. Therefore, very little disturbance to the treated soil can be tolerated. Freshly treated slabs should be protected by polyethylene sheet or other waterproof material, unless the concrete is to be poured the same day as treatment. Protecting treatment from rain and evaporation. Final treatment of the outside walls should be done after all grading and soil disturbances are completed. Trenching involves digging a narrow trench along the foundation wall and then flooding it with a measured amount of insecticide, termiticide. As stated on label, the trench must be next to the foundation wall or masonry work footing of any supporting posts or piers. The trench may not extend below the footing of the foundation wall. Termiticide may be rodded into the soil at the bottom of the trench in addition to being mixed with excavated soil as the soil is replaced in the trench. Varies with soil type and moisture. Wet or tightly packed soils, it is difficult to obtain the needed penetration with the trenching alone. Sandy or loose soils can be treated satisfactorily under normal circumstances. General trenching process: soil is removed some, but not all of the termiticide is poured into the trench. Some, but not all of the soil is backfilled in over the trench and mixed thoroughly with the termiticide, alternating adding termiticide and soil until the trench is filled. Cover the treated soil with 1 inch of untreated soil to reduce the risk of exposure. Rodding may be the simplest form of application. Pesticide solution is applied through hollow steel tubes inserted vertically or horizontally into the soil. The rod is usually made of pipe inch in diameter and 4 feet in length with a handle and shut-off valve at one end. The other end is fitted with a perforated tip to disperse the liquid laterally as well as downward. After rod penetration has begun, chemical flow can start and should aid in the passage of the rod to 3 or more feet necessary to soak the soil at the footings. Usual rate of termiticide application is 4 gallons per 10 linear feet per foot of depth. Spacing is generally every 12 inches. But can be as close as every 6 inches in clay and as much as 18 inches in sand. The objective is to place the insertion points close enough together to provide overlap of the application to ensure there are no untreated gaps. Angling the rod slightly toward the foundation directs the flow against it. Insertion points should be parallel and as close to the foundation as practical. Treated backfill method is used in high-risk situations where there is a well that could be contaminated or where the foundation may leak from rodding or trench application. Treated backfill method steps: trench is dug and the soil is removed. Removed soil is placed on a plastic sheet or tarp. Normal amount of termiticide is diluted and thoroughly mixed with the soil. Once chemical has dried, the soil is replaced. It is a very labor-intensive method and may be used as a form of spot treatment, treating beneath slabs and floors. Termite infestations in houses built with a slab on the ground present serious control problems. It is difficult to get chemical where it will be effective. Sub-slab injections is one method to treat below the slab. Drill a series of vertical holes through the slab close to termite entry points. Space the holes 6 inches away from the wall and 12 to 18 inches apart. Inject termiticide. For sub-slab injections, you must take care to not drill into duct vents, water/sewer lines, or electrical areas to prevent exposure to chemical. An alternative method for sub-slab injections, commonly used in kitchens and bathrooms, is to drill through the exterior foundation walls to the soil just underneath the slab basements, where footings are greater than 1 foot of depth from the grade to the bottom of the foundation. Application can be made by trenching, rodding, or both at a rate for 4 gallons of diluted solution per 10 linear feet per foot of depth. Treat along the outside of foundation walls, as well as along interior load-bearing walls, conduits and piers. Raised cement porches, patios, sidewalks, and driveways. These areas present a special challenge. Extra care and planning are essential to ensure a complete barrier treatment may be carried out by drilling through the concrete or funneling under the concrete next to the foundation wall. No untreated soil should come into contact with any wood portion of the structure. Holes should be drilled 9 to 18 inches apart. Use of termiticide foam is common in these areas. Treating hollow foundation voids involves injecting termiticides into voids in the foundation walls, piers or posts where termites might travel from soil to wood. Typical rate of application is 2 gallons of diluted solution per 10 linear feet at wall or foundation. Multiple brick and hollow tile foundations. Multiple brick foundations should be treated below grade level from the inside and above grade level from the outside with holes placed every 16 inches at the end of every WTO. Stretchers do not drill into the tile directly because it is easily cracked. A thorough grade level termiticide applications to obtain good soil coverage on both sides of the foundation is the best method for treatment. Use of foam with termiticides. The foam acts as a carrier and helps Disperse termiticide laterally through confined gaps and cracks. It carries the liquid termiticide on the spaces between bubbles, not in the bubbles themselves. Foam treatment is particularly well suited for application under concrete slabs. Any commercially available termiticide can be applied as a foam. Common strategy for foam treatment in raised stoops, slab on grade, and other situations where soil is present is to first treat drill holes with approximately of the labeled rate of termiticide as liquid, the other as foam. Example: 3 gallons per 10 linear feet of liquid, and then finish with 1 gallon per linear feet with foam for a total of 4 gallons per 10 linear feet. Foam technology is not a shortcut to thorough coverage, nor is it replacement for conventional application procedures. Only liquids penetrate the soil. To provide coverage along a foundation or wall, exposed soil must still be trenched and rodded, and slabs above depth footings must still be drilled and robbed to inject liquid termiticide. Treatment odors. Common concern is chemical odors, but the problem has been greatly reduced over the years. Clients should be informed there may be some odors for 3 to 4 days after application, and to prevent build-up, structures should be ventilated. Fans may be used to circulate air, but air conditioners should be turned off, and upstairs doors closed. Seal voids where needed, and take special care if there is a furnace or duct work in a crawl space. Operate pumps at 25 and 50 C to minimize splashing, and localized pooling of termiticide application equipment and calibration. Successful termite control depends on the proper selection, maintenance, and use of specialized application equipment. Application equipment and calibration is different for termiticide bait and barriers. Termiticide application equipment must be maintained in good condition, and inspection of equipment is recommended prior to application. Routine replacement of gaskets, hoses, and packings should be done as specified by the manufacturer. Termiticide barriers. Liquid termiticide solutions are applied under pressure and forced into the soil, foundation voids, and other appropriate areas to be fooded. The minimum equipment system or rig would include tank, motorized pump, flow meter, hoses, pressure relief valve, tank agitator, pressure gauge, probing rods with handle, valve, assorted tips. Additional equipment: sub-slab injector, rodding devices, rod extension, spray gun, concrete drills and bits, extension cords, PPE. Termiticide calibration. Proper application requires several important calculations to ensure sufficient quantity of properly diluted insecticide solution is reaching target areas. Accurate mix the product in the number of gallons of finished solution desired. Make sure it has completely incorporated into the mixture. The second calibration step is to apply the termiticide solution at the prescribed rate. Follow the label closely, including amount per gallons, and how to treat different types of soil. Termite baits. The active ingredient of termite baits comes pre-packed and ready to use. There are no dilutions or mixing ratios to calculate. Calibration of termite baits is to install all ground bait stations / receptacles according to manufacturer's directions relative to activity. Do not install stations where termiticide has previously been applied, protecting groundwater and surface water contamination. No matter how small, is serious. Frozen or saturated soil. A general rule is to not treat soil that is frozen or saturated with water. This can increase the chances of runoff, travel through underground channels, or leaching houses with wells and cisterns. Faulty wells are probably the most common cause of contamination. These faults permit surface water to enter the well, usually along the supply pipes that lead into the dwelling. It is difficult to detect a defective well. You should request a well B test for coliform bacteria by the health depot prior to treatment. A positive result means the well is receiving surface runoff, and treatment should not be done. Well's location, distance from the structure and depth should be recorded in pre-inspection notes. Be sure to ask about wells and cisterns as they may be out of sight. If chemical treatment cannot be completed, then mechanical alterations that block termite entrance can be done. If a well or cistern is contaminated, contact the chemical manufacturer and follow the company's recommendation. Sumps and a high water table. Always know where the sump water is located. High water tables, both localized and extensive, are found in many areas. If saturation occurs up to grade, then treatment is unnecessary because termites cannot survive in such an environment. Do not treat beneath basement floors where soil is saturated. Do not apply termiticides into soil with excessive pressure. Only pressure should be applied to aid in rod insertion grades and downspouts. Note the location of drainage pattern from downspouts. ditches, curbs and so forth. Drainage and erosion may carry termiticide away from the treatment site. Do not treat soil that may erode. Check that rainwater does not drain under the structure or into adjacent soil. Downspouts should discharge water away from the building. Termite control and prevention with baits. Baiting is a slow long-term process. Termite baits consist of a palatable and acceptable food material combined with a very slow-acting toxicant. Baiting systems deliver very small amounts of pesticide over a long period of time, up to several months. Baiting may suppress the colony population or control the entire colony by total elimination. Either way, the structure is protected by cessation of termites feeding within the building. The time frame for control depends on several factors such as product selected, application timing, the time to discovery by the termites, the amount of feeding, colony size, and application of other control measures. Baits are placed in plastic bait stations just below the surface of the ground and serviced at the manufacturer's recommended intervals. Pre-baiting with non-treated wood can be done. If termite activity is discovered in the bait station with untreated wood, then replace the wood with termite bait. Commercial baiting products. Applicators must stay in contact with manufacturers and distributors to remain up to date with labels and product changes. 3 types of bait products are currently available: ingested toxicants, biotermiticide/microbes, insect growth regulators, IGRS. Ingested toxicants offer the quickest response, dose dependency and learned avoidance, however may limit this type of product to termite reduction. In localized areas, biotermiticides are derived from fungi, bacteria, or nematodes. These pathogens develop on the infected foraging termites and are transferred to the colony. They may provide localized area control or with optimum conditions. Colony suppression IGRs include juvenile hormone analogs, JAP, juvenile hormone mimics, JHM, and chitin synthesis inhibitors, CSI. These products disrupt the normal growth of termites or block the molting process. They are the slowest of the control types, but have greater impact on the colony. Wood treatments, termiticides, wood preservatives, and borate-containing compounds may be applied to wood to make it less vulnerable to termite attack or to elemite infestations. These treatments often have limited value because of site limitations or special concerns generally considered as a supplement to the soil barrier treatment or other method, and not as a replacement. Wood injection, also known as gallery treatment, involves drilling small diameter holes at manufacture specified intervals into termite-infested wood, then carefully forcing the insecticide into the galleries created by the termites. Is temporary relief and not a cure for a termite problem. If done properly, it quickly kills termites and may prevent swarmers from emerging inside the building. With surface treatment, spraying or brushing insecticides on exposed wood does very little or no termite control. Borates for termite/WDI control are specific formulations developed for use as wood protectants. They control powder post beetles, carpenter ants, wood decay fungi, and above ground infestations of termites. Active ingredient in borates is disodium octaborate tetrahydrate. Borates are non-volatile persistent compounds, are essentially odorless, and have very low toxicity to mammals, may be toxic to plants. Dilute borate solutions can be applied to the surface of unfinished wood, or brushed into the wood, or injected into galleries. Borates must be injected to kill termites and therefore are intended for above ground control methods. Other control methods: nematodes, some species of parasitic roundworms. Nematodes infest and kill termites and other soil insects. This method of control is limiting due to environmental factors. This method of control should be considered experimental at best due to its lack of effective control. Heat treatment. Insects exposed to 120 for more than 30 minutes are killed. Only kills termites within the structure during the treatment. Heat treatment for termites is not a useful alternative in Iowa due to the species of termites active in the state. Freeze treatment. Rapidly cooling termites to approximately -24 5 minutes is fatal. This method often relies on liquid nitrogen, which is dangerous to handle. Fumigation. Not practical control in Iowa, and will not control subterranean termites. Electrocution and microwaves. being tested in other parts of the US to control drywood termites and powder post beetles, but still no use for controlling Iowa's subterranean termites. Physical barrier sand, a long used technique, but sand barriers have not been tested in Iowa usually. A pre-construction barrier, 2 to 6 inches layered sand against the foundation in a shallow trench. That is recovered physical barrier stainless steel mesh, a physical mesh/wire screen barrier placed beneath the concrete slab limited to pretreatment. Only and come with a high pressure tag. No long-term efficacy, and termites have been reported tunneling around and over the screen. Carpenter ants. General ants cannot use wood for, but carpenter ants use wood for shelter and nest construction. Ants are often misidentified as termites. Carpenter ants are shiny black and up to inch in length. There are several species that are reddish brown and as small as inch in length. Excavate irregular gullies inside stumps, logs, trees, porch column, window, and or frames, and other areas. They prefer wood that is naturally soft or wood that has been affected by decay. Their galleries are free of powdery wood and mostly free of sawdust. Sawdust that is inside the nest often contains insect fragments and is a symptom of carpenter ant infestation. Carpenter ant biology. Ants are social insects with a complete life cycle. White legless, grub-like larvae hatch from eggs laid by a reproductive female queen that are cared for by workers, non-reproductive females. The larval stage lasts approximately 3 weeks before transformation into pupa. Pupae are encased in a silk cocoon. Winged adult ants emerge from well-established colonies and fly off to mate and initiate new colonies. Most swarmers develop in late summer, but remain in the nest to swarm early the following summer. Workers are the most numerous and responsible for nest construction, foraging, and caring for larvae. Most colonies have 2,000, 3,000 workers. They are scavengers. They mostly feed on other insects, but the house they will feed on all food scraps, especially syrups, honey, jelly, sugar, meat, grease, and fat. Carpenter ant control. Repairing moisture leaks may not eliminate carpenter ants, and chemical control is usually needed. There are 2 common approaches to carpenter ant control. Direct nest control. Comprehensive treatment. Locating the nest can be difficult. Baits designed for carpenter ants are a recently development and are quite effective. These baits are different to other insect baits because they contain foods and other materials that are highly attractive to carpenter ants. The following practices should help to prevent carpenter ant infestations in homes. Correct moisture problems, such as leaky roof or plumbing. Ventilate crawl spaces to reduce wood decay. Replace rooted, water damaged wood within a structure. Eliminate wood to ground contacts that lead to rot of lower siding boards and sill plates. Remove dead stumps, trees. Remove board piles and old firewood. Remove all nesting sites near the house. To the extent that is practical, store usable firewood off the ground and away from the house. Trim trees and bushes so they do not touch the house. Patch or seal entry points in the foundation. Loose fitting windows, doors, and seams and shrunken or loose caulking powder post all excess beetles. General. Several families of beetles attack wood and by their feeding activity reduce the wood to powder. The name powder post beetle is reserved for beetles in the family Lictidae. Powder post beetle problems are rare in Iowa and chemical treatment is seldom necessary. True powder post beetles attack freshly cut hardwoods, the sapwood of ash, hickory, oak, and walnut to name a few. Females lay eggs in the wood through pores. Larvae burrow through the wood making 1/16 to 1/12 of an inch in diameter holes that are packed with a powder-like sawdust. Larval period is a few weeks to a year, or longer depending on species, and then a much-showed pupal stage. Adults chew holes through the wood surface to emerge and lay eggs for another brood. Damage is done to wood by the larvae. They have a rather specific growth requirements for survival. Wood moisture content must be 32%. Wood starch levels must be 3% or more, and it must be warm from 56 to 96. Many infestations go away on their own due to these environmental requirements. The first step toward control is to determine whether an active infestation is present, which can be done by finding adult beetles, observing fresh sawdust at exit holes, or by plugging all existing exit holes in 1 foot area, and observing additional unplugged holes 6 to 12 months later. If an active infestation occurs, you can replace the damaged wood, or apply properly marked residual insecticide. Kiln drying of wood also kills the insects, but the wood is able to be infested. Vault or tarp fumigation is also an option. False powder post beetles are occasionally found in bamboo or rattan furniture imported to Iowa. These beetles reduce the bamboo to a fine dust that sifts out. Control of false powder post beetles can be done by removing the infested item, as well as vault or tarp fumigation methods. Round-headed borers. They are larvae of certain species of longhorn beetles. The old house borer damages seasoned pine timbers in the eastern United States, but is not found in Iowa. Many common species of round-headed borer attack drying trees and freshly cut logs in Iowa. These larvae may live for several years in air-dried lumber, producing inch-diameter winding tunnels that are packed with coarse sawdust. Evidence of these borers is common in finished lumber. Round-headed borers do not infest seasoned wood in Iowa. Control of them is usually not necessary. Badly damaged lumber may need to be replaced. Wood decay fungi. General wood of most tree species is susceptible to decay. This decay is caused by specific kinds of microscopic fungi that are readily present in the environment. Wood decay fungi grow in the interior of wood and use the wood as a food source. These fungi have basic requirements that include favorable temperature, adequate moisture and adequate oxygen. The temperatures favorable by fungi usually range from 50 to 90. Wood is generally safe from decay at temperature below 35 and above 100. Fungi to not attack dry wood. Moisture content of 20% or less. Decay fungi require a moisture content of 30%. Fungi are living organisms and require oxygen to live. This is why they do not appear in / underwater. There are 3 types of major groups for wood decay fungi. You are only likely to encounter brown rot. Fungi that cause brown rot are able to break down the cellulose component of wood for food, leaving a brown residue of lignin. The final state of wood decay by the brown rot fungi can be identified by the following characteristics: dark brown color of wood, excessive shrinkage, cross-grain cracking, ease with which the dry wood substance can be crushed into powder. Brown rot fungi are the most important cause of decay in softwood species used in above-ground construction in the United States. Brown rot when dry is often called dry rot. This is a bad term because fungus require moisture and wood does not decay when dry. Fungicides cannot stop wood decay once it was started, but it can slow the progress in some cases. The key to control is to eliminate the source of moisture. If moisture is an expected problem, commercially pressure-treated lumber should be used.